And well, what if we did have a square matrix? What about, let's say I take the matrix A to be a 3 by 3 square matrix. So I'll say the entries are 3, 0, 1, 2, 6, 0, and then 1, 4, 5 for the third row. So, well, what if I wanted to compute a power of this matrix? Well, you can. You could do it. You can compute any power of that matrix. But what if I wanted to, say, compute A to the power of 17? Well, that's if I was dealing with numbers, just ordinary numbers, my main concern would be the size of the number. Like for example, 2 to the power of 17 is an incredibly large number. So that would be my main concern with the number. Is my calculator going to be able to even comprehend that number? Because some numbers are so large that your calculator can't even comprehend them. But with matrices, our concern is not so much the size of the numbers as much as the number of operations, the number of arithmetic operations that need to be computed in order to evaluate the power. So, for example, if I wanted to compute a to the power of 2, what would that involve? I'd have to multiply a with itself. I'd have to go a times a. And a is a 3 by 3 matrix. So that would amount to performing a product of two 3 by 3 matrices just to compute a squared. Well, then how would I compute a cubed? Well, I'd have to multiply a squared by a. So I'd have to do another computation or another product of matrices that were both 3 by 3. So and multiplying two 3 by 3 matrices, I mean it's doable. It's certainly doable, but it's not a walk in the park. Remember, there was quite a few entries to compute one at a time just for this product, right? When we were multiplying, how about, let me be specific. Let me look at this one. We were multiplying a 2 by 3 matrix by a 3 by 3 matrix. We did it, it was fine, but each one of these entries required a dot product of two three-dimensional vectors. So if you're multiplying a 3 by 3 matrix by another 3 by 3 matrix, there's even more calculations to do. So the point here is that computing powers of matrices, especially large powers, is very computationally demanding. So that's what I want to finish this comment off with. So it's very computationally demanding.